So today we are going to do shortest spanning tree using Prim's and Kruskal algorithm. Shortest spanning
ম্যাম
tree use হ্যাঁ
ম্যাম আমি এই জয়েন হলাম, আমার একটু লেট হয়ে গেছিল
দিয়ে
ম্যাম।
দিয়েছি attendance.
আচ্ছা আচ্ছা ম্যাম, ঠিক আছে ঠিক আছে।
আচ্ছা, to find shortest spanning tree using Prim's and Kruskal's algorithm. Now, what do you mean by shortest spanning tree? Suppose we have a, weighted graph. Suppose we have a weighted graph. Weighted graph is what? Suppose this is the point V1, this is the point V2, this is the point V3, this is your V4. And the graph is like this. And every edge is associated with a real number. Let V1, V2 be 3, V2, V3 be 5, this one 6, 1, etc. This number, as I was discussing in the last class, this number that may be simply the distance. It may be simply the distance, say within kilometer, unit is say kilometer. This is the distance between 2 points V1 and V2. Similarly, 5 kilometer is the distance between V2, V3, V3, V4, they are 1 kilometer apart, and V1, V3, they are 6 kilometer apart. So this gives the distance between 2 points. That is one possible way. Or it may happen that this stands for time. This is 5 minutes. That means to reach from V1 to V3, a vehicle will take 5 minutes, or we will take, say, 5 minutes. So this is the time. These numbers represent the time. So 6 minutes, starting from V1, it will take 6 minutes to reach at V3. Or suppose we are starting from V3 and within 1 minute we'll reach at V4. This is one way of defining the number. Or it may happen that this distance time, or suppose this is your money spent. We'll say that it cost, say, suppose this is 10. It cost, or say 60, 50, 30. So we are moving by rickshaw and it takes 10 rupees, rickshaw or toto, and it takes 10 rupees or auto to reach V4 from V3. Or suppose to reach V1 from V3, the auto takes 60 rupees. To reach V3 from V2, the auto takes 50 rupees. To reach V1 from V2, the auto takes 30 rupees. So these are the ways, these are the ways by which we define the numbers. That means the numbers associated, they may be the distance between 2 points, they may be the time taken to reach from one point from the other point, or they may be simply the cost involved while going from V3 to V4, any one of this, or that may be something else also. Simply some numbers, some real numbers are associated with the ages. In that case, we call that age a weighted graph. Most of the times it will be the distance between 2 points. But it may not, it may be something else also, but only the thing is that weighted graph means all the ages are associated with some real number. In that case, we call the graph to be a weighted graph. Now, suppose we have to find the shortest spanning tree. We have to find shortest spanning tree of this graph. What will be that one? Shortest spanning tree. Spanning tree means what? Orijit, what do you mean by spanning tree? Last class we discussed about it. Bolo. What do you mean by spanning tree? Spanning tree means, Orijit?
ম্যাম অরিজিৎ বলে একটু বাথরুমে গেছে, ম্যামকে বলে দিতে।
অরিজিৎ বললো বাথরুমে গেছে?
আমাকে
কখন বললো
মেসেজ
তোমাকে?
করলো, বললো
কখন
বললো
বললো
5
তোমাকে
মিনিট,
এটা?
এই বললো একটু আগে মেসেজ করলো ম্যাম।
আসতে বলো। এরকম করলে কিন্তু হবে না। হ্যাঁ, একে তো অরিজিতের কোনো ক্লাস পাস করতো না, কোনো রকম ভাবে জাস্ট এই এপ্রিল মাসে 75%টা বলেছে বলে ও পরীক্ষাতে বসতে পারবে, না হলে ও পরীক্ষাতে বসতেই পারতো না। তার মধ্যে ক্লাস জয়েন করে দিয়ে যদি বেরিয়ে চলে যায় তাহলে আর কিছু করার নেই। কিন্তু অরিজিতের হলো লোয়েস্ট অ্যাটেন্ডেন্স, এবং যদি একজনকে আটকাতো ক্লাসে পরীক্ষায় না বসতে, সেটা অরিজিৎ হতো। ও শুনতে পেলো আমি ওকে জিজ্ঞেস করছি, তারপরে ও তোমাকে মেসেজ করলো ও বাথরুম গেছে? শায়ন বলো, what do you mean by shortest spanning tree?
শর্টেস্ট মানে কানেক্টেড থাকবে না একটা এজ।
না 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 না, স্প্যানিং ট্রি আগে বলো, শর্টেস্ট পরে হচ্ছে। what do you mean by spanning tree, শায়ন? what do you mean by
স্প্যানিং
spanning subgraph? Spanning subgraph means what?
মানে প্রত্যেকটা এজ জোড়া থাকবে না, একটা না একটা এরকম ওপেন থাকবে।
Acha, spanning subgraph means all the vertices must be present. That is what we call spanning subgraph. All the vertices of the original graph must be present. All the vertices must be present. Now, this is what we call spanning subgraph. Now, some of the edges may be present, some of the edges may not be present. Now, spanning tree Vaibhav, what do you mean by spanning tree Vaibhav? What do you mean by spanning tree?
मैम स्पैनिंग ट्री में सब कनेक्ट रहता है।
सब कनेक्ट रहेगा, सब तो एक तो कनेक्ट रहेगा और कहीं पे भी लूप नहीं होना चाहिए। हाँ, मतलब सर्किट नहीं
यस मैम,
होना
मतलब
चाहिए।
सेल्फ लूप नहीं बनेगा।
सेल्फ लूप नहीं, कोई भी लूप नहीं बन, मतलब सर्किट नहीं बनेगा। हाँ, तो उसको
Yes,
हम
ma'am.
लोग स्पैनिंग ट्री कहेंगे। तो नाउ वी हैव टू फाइंड द शॉर्टेस्ट स्पैनिंग
और
ट्री।
मैम और आपने क्या बताया था, रिटर्न नहीं करेगा उसी पोजीशन पे?
क्या फिर से बोलो?
मैम आपने
वही
बताया
तो
था
हुआ,
ना।
सर्किट हुआ।
हाँ, उसी को तो हम लोग सर्किट कहते हैं ना। मतलब वापस अगर आ जाए ना किसी पॉइंट पे, मतलब जैसे दिखा रही हूँ मैं,
मैम नहीं, वापस नहीं आएगा
वापस
इसमें।
नहीं आएगा। ये अगर ऐसे ही अगर डाल देना तो फिर वो तो वापस आ गए। जैसे V2 है, V1 है, V3 है, V1 से लेके
हाँ,
V2 तक गया, V1 से लेके V3, फिर दोनों को ज्वाइन कर दिए, तो दैट बिकम्स अ सर्किट। हाँ, V2 से स्टार्ट किए, वापस V2 पे आके रुक रहे हैं, तो दैट इज अ सर्किट। दैट इज नॉट पॉसिबल, नॉट परमिसिबल इन स्पैनिंग ट्री। If we don't join
ओके
this
मैम।
edge, then that's a spanning tree. V1, V2, V3. It's an example of a spanning tree. Not spanning tree, it's an example of a tree. Then we join this with V4. That is an example of spanning tree. Okay. Spanning
अच्छा
tree
हाँ मैम,
मतलब,
यही बोली।
हाँ, स्पैनिंग ट्री मतलब वो ट्री होना चाहिए और ऑल द वर्टिसेस,
सर्किट में।
हाँ, कहीं पे भी सर्किट फॉर्म नहीं करना चाहिए।
ओके मैम।
অরিজিৎ ঢুকেছো ক্লাসে? অরিজিৎ,
ইয়েস ম্যাম।
হ্যাঁ, এরকম ভাবে চালিয়ে চলে যাবে না। হ্যাঁ, মনে থাকে যেন আমি আবার ক্লাসে বলেছিলাম, একজন যদি আটকাতো সেটা তুমি হতে পরীক্ষার জন্য। এই নেহাত
সরি ম্যাম,
অনলাইনের হয়ে যাওয়ার জন্য বেঁচে গেছো। তোমার
সরি ম্যাম।
অ্যাটেন্ডেন্স সবচেয়ে কম, তারপরে কি করে এটা হয়? কি করে ক্লাসে এরকম খুলে দিয়ে চলে যাওয়া হয়?
নো ম্যাম, আই ওয়াজ ইন দি ওয়াশরুম।
Now you are here because Anish called you. Anish or কে আমাকে এখানে বলেছিল, he called you, that's why you are here now. Anyway, be attentive in the class, huh? Okay. Acha, now we have to find shortest spanning tree. Now spanning tree means all the vertices must be present. That is what we call spanning subgraph. And tree means no circuit should be formed. It should be a connected circuit-free graph. Now shortest spanning tree. Obviously V3 and V4, there is only one way to reach V4. There is only one path to reach V4. That is, we will join V3 with V4. That is your 10 units. Then either we may go along this route, V1 to V2, then V2 to V3. Either we may use this path. That will cost 30 plus 50. That means 30 plus 50 plus 10 equal to 90 units. That is one way by which we can find the shortest spanning tree. Another way is, do not join this 50 units. 30, then 60 plus 10. So 60 plus 30, 90 plus 10, that will take 100. That weight will be 100, which is greater than 90. So we are not going to join this 60. We are not joining this 60. So we are not joining 60. So that means this is your 50 units. The shortest spanning tree is this. V1, V2, then V2, V3, V3, V4. Is the concept clear? What do you mean by shortest spanning tree? Is it clear?
Yes, ma'am.
Spanning tree
Yes,
means
ma'am.
the shortest spanning
Yes,
tree
ma'am.
means the weight should be minimum. The weight should be minimum. Weight may be distance, it may be the time taken, it may be anything else, but that should be minimum. For that, if you look at the previous figure, if you look at the figure, V3, V4, there is only one connection from V3 to, if we want to reach V4, then we have to move along V3, V4. There's no other way out. So this chain is obvious. This chain we have to join. V3, V4, we have to join. Apart from this V3, V4, we may either join V1 with V3 or V2 with V3. Now, since this age is 60 units and this is 50 units, since we are going to find shortest spanning tree, so we'll consider this 50 units. And this is your 30. So total age, total weight will be 30 plus 50 plus 10, that is equal to 90. Okay. Now, this is the concept of shortest spanning tree. Now, we are going to find shortest spanning tree using Kruskal algorithm first. Let us find the shortest spanning tree using Kruskal algorithm. Kruskal's algorithm for finding shortest spanning tree in a graph. First of all, if there is any self loop, we have to remove it. And if there are parallel edges, we have to consider that one which is having lesser weight, which is having lowest weight. For example, suppose we have a graph like this. V1, V2, V3, V4, V5, V6. And the weight of the edges are, suppose this self loop is 6, this is 5, 2, 3, 1, 7, 3, 9, 2, 4. Suppose these are the weights of the edges. First thing what we'll do, we will remove the self loop, and if there are parallel edges, we will consider that one which is having lesser weight. So that means our new figure will be this one. There is a self loop at the point V3, we are going to remove it. Then there are two parallel edges. One is between V6 and V4, there are two parallel edges. One is of 3 units, other one is of 9 units. So obviously we are going to remove the 9 unit portion and we are keeping that 3 units. 3 units, this is also 3, this is 5, this is 2, 7, 1, this is your 2, this is 4. Is this portion clear? What I have done, is it clear to all of you? First step, this is the first step.
Yes, ma'am.
Okay, so that is the first step for Kruskal algorithm, as well as the next one is Prim's algorithm. For that one also, this is the first step. One thing I forgot to mention, আমি ইয়েতে লিখে দেব, WhatsApp গ্রুপে লিখে দেব, a tree with n number of vertices always has n minus 1 number of edges. For example, let us consider this tree. It's a tree. There are 2 vertices, so only 1 edge is there. Now let us consider a tree with 3 vertices. It's a tree. 2 edges are there. Number of vertices 3, number of edges is 2. if we continue, 1, 2, 3, 4, there are 4 vertices, number of edges is 3. We can't have more than 3 edges because any edge, if we join, it will give you a circuit, which is not permissible. Similarly, if we have 1, 2, 3, 4, so if we have 5 vertices, 1, 2, 3, 4, 5. If you want to draw a tree, it should be like this. This one or this one, etc. So 1, 2, 3, 4, 5, 5 vertices, edges 1, 2, 3, 4. 4 edges. So always a tree with n number of vertices has n minus 1 number of edges. Remember that? A tree with n number of vertices always have n minus 1 number of edges. Now, first step, is it clear to all of you? What I have done, I have removed self loop. And if there exists parallel edge, I am removing the edge which is having higher weight, which is having greater weight. So now this is the new figure. Is it clear?
Yes, ma'am. Clear.
First step is
ma'am.
clear, no?
Yes, ma'am.
Okay.
Yes, ma'am.
Okay. Now in Kruskal algorithm, what we do, we write the edges in order of increasing weight. We write the edges in order of increasing weight. Weight, edge. First, lowest weight is what? For this particular graph, what is the lowest weight?
1 is there.
1. 1 is the lowest weight, that is corresponding to V2, V6. 1 is corresponding to V2, V6. So this is your V2, V6. Next weight is 2. There are 2 2s. So 1 is corresponding to V5, V6. Other 2 is corresponding to V1, V3. Next is your after 2, that is 3. Next weight is 3, corresponding to V4, V6. And another 3 is V2, V3. After 3, this is your, after 3, 4. 4 means V4, V5. 4, V4, V5. Next is 5. 5 means V1, V2. 5, that is V1, V2. And after that, 7. 7 means V3, V4. I think I have taken all the edges, no? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. Yes. Now we will start with the lowest weighted edge. We'll start with the lowest weighted edge. So that is your V2, V6. Lowest weighted edge is your V2, V6, weight being 1. It's your weight 1, lowest weighted edge V2, V6. So I am joining V2 with V6. This is V2, this is V6. Weight is 1. I'm joining V2 with V6. Then after this, next weighted edge is V5, V6 or V1, V3. Let us take V5, V6. V5, V6, that is your 2. Next is one more 2 weight is there, that is corresponding to V1, V3. So this is suppose V1, I'm joining V1 with V3. That is again 2. Okay. Next is your 3, V4, V6. V4, V6. I join V6 with V4. Whether I have drawn a straight line or curved line, that doesn't matter. Here it was a curved line. Now I'm drawing a straight line. That doesn't matter. Only the connectivity matters. So V4, V6. Next is your V2, V3. V2, V3. V2, V3 I'm joining. V4, V6 was 3. V2, V3 is also 3. Now see how many points were there in the original graph. How many points were there? How many points were there? There were 6 points. So now see, a tree with n number of vertices should have n minus 1 number of edges. So if there are 6 vertices, the tree will have 5 edges. Already we have, yes, already we have got 5 edges. So this is the required shortest spanning tree. Tree looks like this. Tree is this one, then this one, this one, this one, this one. This is 2, this is 3, 1, 3, and 2. This is V1, second one is V3, this is V2, V6, V4, V5. This is the required shortest spanning tree, and the weight of the tree will be your weight of the tree is 2 plus 3 plus 1 plus 3 plus 2. 11. Weight of the tree is 11 unit. Is the process clear? Kruskal's algorithm clear to all of you? I'll show more examples,
Yes,
but
ma'am.
is the process clear? Is there anyone who is not understanding Kruskal's algorithm?
मैम ये वेट कैसे निकाले हैं?
वेट सब एज जितने भी एजेस में हमने लिया ना उन सबका वेट को ऐड करना है.
अच्छा
जितने भी एजेस लिए हैं वो ग्राफ मतलब वो ओरिजिनल ग्राफ में जैसा वेट है यहाँ पे भी वैसा ही वेट रहेगा, सबको ऐड करना है. सो दैट इज गिविंग यू द वेट ऑफ द स्पैनिंग ट्री. প্রসেস ক্লিয়ার?
ম্যাম
হ্যাঁ বলো.
ম্যাম এই যে আপনি এখানে ওয়েট গুলো লিখেছেন ওইখান
হ্যাঁ।
থেকে তিন অবধি কারণ চুজ করলেন 4 5 7
ওইটাই বলছি. A tree with n number of vertices has n minus 1 number of edges. Since we are having 6 vertices, so the tree should have 5 edges. Once we have got 5 edges, আমি ওখানেই ছেড়ে দেবো. We will leave at that stage.
আচ্ছা
হ্যাঁ, because we are going to find shortest spanning tree. ঠিক আছে, spanning tree whose weight is minimum. আমি আর পরের দিকে এগোবোই না. Once we get 5 edges, we'll stop at that stage.
ওকে ম্যাম.
Let's do one more example. It's a worked out problem in book. It's a worked out problem, huh?
ম্যাম বলছি আমি একটু ল্যাপটপে জয়েন হতে পারি ম্যাম?
হ্যাঁ হো.
আচ্ছা
এক কাজ করবে এমনি, আচ্ছা ঠিক আছে, কারণ আমি 8 মিনিটে এটা শেষ হয়ে যাবে, পরে আরেকবার 8 মিনিট পরে আবার নতুন লিংক, এই লিংকটা দিয়ে ঢুকবে. হ্যাঁ
আচ্ছা 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 ঠিক আছে ম্যাম, ঠিক আছে.
আচ্ছা, these are A, B, C, D, E and F. I've slightly modified this is a worked out problem in your book. I have slightly modified it. 1, 3, 5, 2, 3. Three. This is 5, 4, 4. Okay, so this is the graph A, B, C, D, E, F. First of all, number of, and we are going to find the shortest spanning tree in the graph. The graph is a weighted one. First, tell me how many edges will be there in the graph? How many edges will be there in the, I'm sorry, in the spanning tree? How many edges will be there?
n minus 1.
N minus 1, since there are 6 vertices, so n minus 1 means 5 edges. Huh? So once we get 5 edge, we'll stop at that stage. First, what we have to do, we have to draw the figure once again by what? We should draw the figure once again by
Removing self loop
removing self loop
Removing the
and
loop.
parallel.
and
And
parallel
parallel
edges.
edges. Huh? Removing
parallel
self loop and parallel edges. So self loop, there is a self loop at the point F. We are not going to join it. We are removing it. Okay. And there are parallel edges at the points
We will
BC.
remove-
Joining BC, there are parallel edges. One edge is of weight 2,
Yeah,
other
line
one
will
of
be removed.
3. So जो 3 है उसको हटा देंगे, उसको मिटा देंगे. Similarly, in between C and D, there are two parallel edges. One is 2, other one is 9. 9 को हटा दे रहे हैं. So we'll consider CD.
जिसका वेटेज बड़ा हो उसको हटाएंगे ना?
हाँ, उसको हटाएंगे क्योंकि हम लोग शॉर्टेस्ट स्पैनिंग ट्री निकालने के लिए जा रहे हैं. हाँ, हमें शॉर्टेस्ट स्पैनिंग ट्री निकालना है, तो इसलिए जिसका वेट ज्यादा हो उसको हटा देंगे. ये रहा 3. This one is 2. This is your 1. Now this EB, that is 4. Then AC, that is also 4. Then AE, that is your 3. A3, EB 5. No, EB, no, I'm sorry, EB 4. This is also 4. FD 5. Have I drawn all the edges? I think so. After removing self loop and parallel edges. Now let us
A से D तक नहीं कनेक्ट की?
A से D तक, हाँ, A और D के बीच में भी 4 वेट है ना. हाँ, A और D को ज्वाइन करना है, वो भी 4 है, मतलब 3 4 है, या फिर ये वाला 5 था.
मैम अब हो गया है.
हो गया ना. अच्छा चलो, ये वाला 4 है. अच्छा, ये मैंने 3 4 कहाँ पे लिखा? यहाँ पे तो 2 था. ए और सी के बीच में वेट है 4, EB के बीच में वेट है 4.
मैम आपने वो A और D का 4 लिखा हुआ है पर लाइन नहीं किया था आपने.
ए और डी का है ना. हाँ 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 हाँ. और ये 5 है. ये
जो
F से लेके D तक वेट क्या था? F से लेके D तक. यहाँ पे शायद ये मैंने वेट नहीं डाला था. यहाँ पे ये 4 होगा.
F से D वाला है. हाँ,
ये
C
वाला
के
ना.
बीच में 2 दोनों लिखा हुआ है.
कहाँ पे? यहाँ पे 2
D
है,
और C.
यहाँ पे 2 है, यहाँ पे 4 है, ये फिर से
आपने
4.
मैम
F और
आपने
D का वेटेज मार्क नहीं किया.
किसका?
मैम एक्स्ट्रा 4 लिखा हुआ है D और C के बीच में.
D उसके बीच में, मतलब यहाँ पे 4 होगा. अच्छा ठीक है, चलो.
बट आपने F और D में वेटेज नहीं दिया है.
FD यहाँ पे है ना.
हाँ.
FD
हाँ,
यहाँ पे. अच्छा, तो ये 5 है EB के लिए.
हाँ EB के लिए है.
ये 5 है EB के लिए. फिर ये वाला हो जाएगा, EB के लिए 5 हो जाएगा. और ये F और D के बीच में FD के लिए चलो 6 दे देते हैं, तो FD का वेटेज 6 हो जाएगा. फिर ये ठीक है.
हाँ, हो
चलो,
गया.
ओके, चलो, वी आर हैविंग लेस देन 2 minutes लेफ्ट, तो ये वाला जल्दी कर लेते हैं. हाँ, तो वेट क्या है? 1. Only one is there. Then 2. There are 2 2s. 1 for AB. There are 2 2s. 1 is for CD. Other one is for BC. Then how many 3s are there? 1 2 3 4. 1 is for AF. Second one is for FE. Third one for DE. and then AE. Then how many 4s are there? 2 4s are there. One is for AD. AD, next 4 is for AC. Then 4 के बाद है 5 for BE and 6 for FD. 6 for FD. Acha. We'll start with AB. We'll join A with B. Huh? We are starting with AB and we are joining A with B. ये खत्म हो जाने के बाद वापस उसी लिंक में ज्वाइन करना 2 मिनट बाद. ठीक है. अच्छा चलो. So we are first joining A with B. AB. That's the first step. Then CD. 2 units. CD. CD. There's the second one. BC. BC. That is also 2 units. AF. AF. 3 units. FE. अच्छा, number of A's हमें चाहिए 5. हाँ? FE. FE. FE is your 3. 1, 2, 3, 4, 5. AB क्या था? We have got the shortest spanning tree. Huh? 1, 2, 2, 3. 3. This is the shortest spanning tree, and weight of the tree is 2 plus 2 plus 1.